Alright, welcome. This is the Properties of Water lecture, and this is for outcome 2. Right, and so today we're going to be talking about the properties that make water unique and how life takes advantage of those properties. Okay, so let's go ahead and look here at how that works. There we go. Alright, so first off, we're going to understand why water has all of these properties. And the root of that is water is what's called a polar molecule. Okay, now a polar molecule is one where the electrons have this unequal sharing. Okay, and so as we learned in the last outcome, electrons have a negative charge. Okay, and oxygen, it's a bigger, more strong atom, and so it's going to pull those electrons more strongly towards itself than the hydrogens. Okay, so it's going to give itself a slightly negative charge because of those electrons. Now hydrogens, because they're not getting the electrons as much, they're going to have a slightly positive charge. Okay, so this sets up like a little magnet with positive and negative ends. And if you remember, like a magnet, opposites attract. Okay, so let's see how water interacts with itself. All right, so in this picture here, okay, the red is an oxygen and the white are the hydrogens. Okay, and as you can see, that the hydrogens are being drawn towards the oxygen of another molecule, and it's forming this little hydrogen bond. It's called the hydrogen bond. Okay, a little magnetic bond, if you will. Okay, now water is making and breaking this millions of times a second as it's moving around in the glass. Okay, now when you increase water, something interesting happens. Okay, the water molecules start moving faster and faster. And as they move faster and faster, they have to form more and more and more and more bonds. Okay, so that's kind of what's going on when you heat water. Okay, when you cool water down, actually the exact opposite happens. You make fewer and fewer and fewer bonds until basically the water atoms themselves are holding still, just kind of jiggling in place. But they still kind of maintain these bonds with each other. And as you can see in this picture, it creates this kind of cool lattice structure, a 3D, it's a crystal, and there's this big space in the middle of these bonds. Now what this sets up is ice, the solid form of water, is less dense than its liquid form. Okay, and you can see this in icebergs. So icebergs are solid water and they float. Now this is exactly opposite of all other substances on Earth. In most other substances, the solid form sinks in its liquid form. Okay, so let's just imagine in a world where ice sank. Okay, so right now ice forms kind of at the top of lakes and oceans and such, and it allows plants and animals to live underneath it. Now if that ice sunk, right, it'd sink to the bottom of the lake or ocean, and in the summer when it got warmer, it wouldn't melt as quickly or at all, in the very bottom of the lake or ocean. Okay, so it set up this very weird system where only the very top of the water would be available for life. Okay, and we wouldn't have these nice deep oceans and such. Okay, so it's kind of, I'm skeptical that life could exist in that situation. Okay, so an interesting property that is, something you may not have thought about that's important for life. Ice floats. All right, so another interesting property is what's called cohesion. Okay, so because this water is forming these bonds with itself, it's slightly sticky to itself. Okay, and you can see in the drop of water here, that's why it's kind of holding its shape, if you will. Now, if you've ever seen like the Jesus lizard or those water skimmers, they take advantage of this because water has a surface tension. Okay, so these water molecules at the surface are bonding with each other. Okay, and they're kind of keeping their form. And so lizards and these insects can kind of glide across the top without sinking. It's a kind of a property of cohesion that they're taking advantage of there. Okay, the exact opposite of that is adhesion. Okay, so water is sticky to other polar molecules. Okay, so if the other molecule has a positive and negative charge, water will be attracted to it. And as you see on the leaf here, you see these droplets of water that should be running down the leaf but aren't. Okay, now plants also take advantage of this in another way. This is how they bring water from their roots up to their leaves. Okay, and in short plants that's maybe not so impressive, but when you think of like a redwood tree or something like that that's several hundred feet tall, and that water has to travel that distance, okay, that would be a lot of energy that the tree would have to expend just bringing water up to the top, okay, if it wasn't for this adhesion. Okay, and we'll talk about, it's called capillary action, and we'll talk about it more later. Okay, just know that it exists and it's a property of adhesion. Okay, high specific heat. This means that it takes water a lot of energy to boil. Okay, and the reason for this is these hydrogen bonds have to be broken more and more and more as you heat it up. Okay, so you have to put, for a given amount or weight of water, you have to add a lot more heat than, say, something like liquid nitrogen or something like that. Okay, so that's an important property. And then one way we take advantage of this is evaporation. Because it takes a lot of energy, okay, most of the water is not going to boil, but individual little water molecules can gain enough energy to kind of jump off. Okay, and this jumping off is called evaporation. So think about like if you wet a sidewalk during the day and you come back like a little while later, it's going to be dry. Where'd that water go? It didn't boil, right? It just evaporated off. Okay, and then living things take advantage of this evaporating to cool themselves. So when you sweat, what you're doing is you're putting this water in your skin and it's evaporating, and that energy is being lost and cooling you. So another way that we take advantage of this kind of unique property. All right, last one I'm going to talk about is pH. Okay, pH is the measure of how many hydrogen ions are in solution. Okay, and it's on the scale of 0 to 14. Okay, and 7 is neutral. 7 is pure water. Okay, and water is neutral. Okay, if you think about H2O. Okay, so hydrogen ions are what make acids, and hydroxide OH negative ions is what make bases. So water is exactly one of each, right? It's one hydrogen ion and one hydroxide ion, H2O. Okay, so it's exactly neutral. Okay, now as you start adding hydrogen ions, you move up in acidity. Okay, so you go from 7 to 0. Now this is a logarithmic scale, so going from 7 to 6, that's 10 times as acidic. Okay, so from 6 to 5, that'd be 100 times more acidic than water. Okay, and so on and so forth. Okay, and then the opposite of that would be basic. Okay, as you increase the hydroxide ions, okay, you get more basic. And it's the same logarithmic scale. So going from 7 to 8, okay, 8 is 10 times more basic than 7. Okay, 9 is 10 times more basic than 8. Okay, and so on and so forth. Okay, now if you look at this, it's kind of interesting that a lot of household cleaners are basic. And the reason for that is acids react with metals and bases typically don't. So if you're going to be cleaning your house where there might be metals, you want to use a base and not an acid. At high concentration levels, they act about the same. So don't think that acid is like more dangerous than a base. It's not. A base will also give you a similar chemical burn. Okay, and we'll play around with this a little bit later. Okay, so that's kind of my talk this time. When we do the lab, we're going to investigate some further properties of water, but these are the 4 basic ones I want you to know going into that lab. Okay, so good luck, and if you need any help with the assignments, again, hit me up in class or the tutoring sessions on Tuesday and Wednesday. Okay, thanks guys. See you later.